Hello everyone, my name is Eric Dallo, and today I'll talk about how to turn your editor into a Clojure IDE with Clojure-lsp. First, about who am I? So I'm a software engineer that works at Nubank. Nubank is a huge company with more than 40 million customers, a lot of software engineers, more than 1,000, more than 600 Clojure microservices, which is a lot. So I can say there is a lot of Clojure code there. Some tech subjects that I like are Emacs. As you can see, this presentation is on my Emacs. So Emacs is my favorite editor. I really like Linux, especially NixOS, which is my operational system, which is a really cool operational system that I recommend you take a look. It's an immutable pure operational system using the Nix language. And I really like the LSP as something that I really search for and study in other languages as well. You can see my open source projects. Besides ClojureLsp, I'm the maintainer of other LSP related projects like DAppsBean is not related to LSP, but it's a project I'm the maintainer. lsp-mode, I'm one of the maintainers, along with a lot of cool guys. lsp-dart, so the Dart/Flutter language, I'm the maintainer of lsp-dart, which is the LSP client for Emacs for Flutter/Dart, Cover, and probably some small ones. All right. Let's start with what's LSP. Before LSP, there is no easy way for an IDE or a text editor to add the same features for a language in other editors, actually. So imagine back in 2014, I think, Microsoft was creating the VS Code editor, and Microsoft faced this issue, which was I need to implement all the features of one language again. Like there are already other editors that have this feature, have this support for this language, and I need to implement all by myself. So they started working on something, some kind of standard that is the LSP, that stands for Language Server Protocol, which is just a protocol, just a standard for that tells to the editor and to the language how they should behave in some common way to provide those features. So before LSP, each editor needs to implement the same features that the other IDE is implemented. But with LSP, this can be integrated in some program, some project that will work for all or should work for all other editors. So the LSP it has two parts, two core parts that are the client and the server. So you can see that a client is just the editors, so Emacs, VS Code, Vim, and since LSP is something kind of new, those editors doesn't have this built-in, so you need another packages like lsp-mode. I think only VS Code has the LSP built-in into the editor. So for other editors like Emacs, Vim, Sublime, you really need another package for this. IntelliJ also has this IntelliJ LSP plugin, which is really cool. And the server, that is the program, the application that will handle that understands this language, right? So the LSP server for Clojure is ClojureLsp. There is, for example, for Scala, there is Metals, and oops, and there are new languages like Dart that has the LSP server built in into the language, like the Dart one, which has the Dart SDK. So this really makes easy to use LSP with those languages. And how this works. So that is the client server communication that needs to follow just the JSON RPC standards. So the client or the server send JSON requests to the other and wait for the response. Or they can send just notifications, which are just requests without response. So that's what is the LSP communication. It's just JSON following a standard that's sent from one to another. Which features LSP can provide? Why should I use LSP? I will show you later, but I'll show you later more details about which features ClojureSp has, but probably most of the LSPs have the find definition, find all the reference of a function, implementations for language that this makes sense, diagnostics that are the link, that is the linked feature, completion, renaming, format your code action. So are just features that make your editor not just a text editor, but an IDE, a tool that can help you really enhance the development of that language. There are other protocol standards for custom features. Like imagine I have a feature that makes sense I have on ClojureSp, but it doesn't make sense to have on Scala. So the protocol allows you to create these custom features, which is something really useful. All right. So ClojureSp, as you know, is the LSP server for Clojure. Some facts about ClojureSp: it's completely open source, so you can find all the code on GitHub. This really helps evolve this tool. So any issues you can report on the repository. Contributions are very welcome. So making this feature open source really help the community. It's implemented in Clojure, which it can sound kind of obvious, but the LSP server doesn't need to be implemented on the language that will attend. So you can see a lot of other LSP servers implemented on TypeScript, which there is this lib that already makes your life easier to use LSP features. ClojureSp is compiled with GraalVM. This is something we did recently on this year. It's something that should make the ClojureSp, let's say, easier to use. You don't need Java installed. It should improve the performance, as the result of this compilation is a native binary that can run on the most famous operating systems like Linux, macOS, Windows. So this this is a fact. Let's say, oh, it uses a lot of famous Clojure community libraries. So since it's made in Clojure, there are a lot of libraries that help to handle the Clojure code, parse the Clojure code, and analyze this code. So there is ClojureSp uses CLJ Condo under the hood for a lot of features. So ClojureSp needs to know about your code, needs to know what is this token, for example. So it uses CLJ Condo, which scans the project and the class path, making a lot of features available for ClojureSp. Also, there is the diagnostics, which is the base of CLJ Condo, which provides linting. ClojureSp uses rewrite CLJ, with another tool to refactor and edit the structure of your Clojure code. So all refactor features from ClojureSp use the rewrite CLJ library. There is CLJ-fmt, which is the really famous library for formatting the code. With the format LSP feature, ClojureSp provides using CLJ-fmt. All right, so in Clojure, we have the REPL. Clojure, it's a language that really uses the REPL, and probably a lot of people say that can't work with Clojure without the REPL. I think that this is related to the fact that Clojure took so much time to has his own LSP. So a lot of languages has the LSP, like Java, which you basically it's very hard to work with the Java language without the LSP and its features. So it's not there are people that say that or think that I can't use the LSP and the REPL together, but this is not true. You can actually use both together, and they work very well. The only issue is that there are packages, for example, for Emacs that has not just REPL integration, but a lot of cool features, which this is nice, but can conflict with LSP. So you need to choose which feature you want to use from LSP or REPL. I will talk about this later. All right, so LSP means static analysis, right? So everything that can be done statically means that it's a good place for LSP. So code navigation, refactor on the code, feedback about warnings, errors. These are things that work well with LSP. And the REPL I see, in my opinion, is just something that I use during runtime, right? So LSP, it equals to runtime. So you need to start your REPL, you need to wait for the REPL jacks in, and you can use for example, run tests, evaluate some things, even debug your code. So I use the REPL when I really need to know what the result of this function, of this form, and for everything else, I actually use LSP, which for me works very, very well. So this is what I recommend for you. You can use the REPL to refactor code. There are packages that do that, but I just think that every time I need those features, I need to set up a REPL, and sometimes I just want to navigate through the code and have some quick feedback about this. So I think the LSP works better for those cases. And recently we added the ClojureLsp API, which is something really cool that ClojureLsp has now, which it makes this true. ClojureLsp works not just on editors. So this is kind of confusing, but you can use ClojureLsp outside the editors to make something with your code or read your code and return to you the feedback. So let's take a look. That is the CLI interface. So you can call ClojureLsp clean ns, which will call the clean namespace feature for ClojureLsp. For the whole project, you can filter some namespace, which is really cool. You can format the code, which will, in the end, call the clj-fmt library. You can even tell ClojureLsp to not format my code, just tell what is different or what is not format with the dry option. So we have the two features. You can fix the lint or just lint. And yesterday on the latest release, this is available too, which is the diagnostics that CLJ Condo provides. So it's a all-in-one tool. You can clean your code, format your code, or just lint with CLJ Condo. I really recommend you take a look on this feature. And there is to the API. So you can call some features from ClojureLsp from the API, like I can tell ClojureLsp to rename a variable from my code to another one. This is something new and really cool. For example, you can start your repo and use this with ClojureLsp. So you don't need to use the LSP inside your editor. You can use the ClojureLsp inside your repo, which is something probably mind-blowing. And there is also the CI. So there is two libraries which help you set up ClojureLsp for your project. So if your project is a line 1 using LineGame, you can use the line ClojureLsp plugin, which is just a plugin that runs ClojureLsp. Or you can use the setup ClojureLsp GitHub action for GitHub projects. So you can configure to lint during pull request reviews, or you can fix. Some people like to make a new commit fixing the lint, so this works too. All right. Let's take a look how to set up the ClojureLsp, so I can show you some of the features. There is two ways to install. There is the automatic installation and the manual installation. The automatic is provided by some editors like lsp-mode for Emacs. That is the automatic installation feature. Or Calva for VS Code, which has ClojureLsp built-in. So you don't need to worry about installing ClojureLsp at all. There is a manual installation which you can install using Homebrew. You can download from the GitHub releases, use the install script from the repository, and other options like Nix users, scope for Windows. All right, after installed the server, we need to set up the client, which is our editor. I will use Emacs as an example here, but each editor has its own way to install the LSP's client, like I said before. So this is a simple, really simple Emacs code to install the lsp-mode using the use package. you say here that for those major modes, you want to call LSP. So when you enter on Clojure mode, Clojure script mode, it will call the LSP command that will start the LSP server and so on. Something I didn't mention before is that the server is not a daemon. The server is just a process that runs, that the editor is responsible for spawning. So it's just a process. It's not something that I need to run on my terminal at background or something like that. So you don't need to worry about this. The client will should know how to launch the server. Here are some configurations. This one are related to performance, so are recommended by the lsp-mode package, and this other one are optional, but that can enable some features. So this first one is related to point to the server. So if you install the server via some other way that is not available on your path or something like that, you need to point to this ClojureSp binary with this variable. There are some features you can enable that are not enabled by default, like the lanes, code lanes, that are a really cool feature that I will show you. There is the semantic tokens, new feature from the latest LSP that I'll show you too. Like I said before, there are a lot of features from existing Emacs Clojure packages, like CLJ refactor and cider. So those features can and will conflict with LSP. So you need to choose which one you want to use. So here I'm disable some features from CLJ refactor and cider that will conflict with LSP. But if you want to use those features but not the LSP ones, you can just comment this one and uncomment this, and everything should work as before. All right, we have here some other optional packages that can enhance the LSP user experience. Like UI, it's optional, but I like some of those features that can provide some UI features to LSP mode. For Helm users, there is the Helm LSP. For IDE users, the LSP IDE that adds other features to LSP mode. And LSP Trimx, which is use Trimx under the hood to provide other features like list all the errors on my project or cover hierarchy. And that's it. All right, so let's take a look at some demo. So this is the ClojureSp web page. Here you find everything about ClojureSp, all the available settings, all the available clients. So I want to know if my client supports ClojureSp. Here we have some documentation about a lot of clients. You have more details about, let me see. You have the installation instructions with more details. The API with details about how to use the CLI or the API. And we have the features page, which brings all the features available in ClojureSp. So here you can find a lot of GIFs and other features available with tips for the Emacs users, Space Emacs users. So this should help a lot of users. Let's try the local sample I have here. I have a really simple project, which is the sample here. So it's a line project with a project.clj. It has a source with only 3 Clojure files, and we will use ClojureSp on this project. So let me open this project. Let's start with the project CLJ. So it's a really simple project, and you can see it's using the line game ClojureLsp plugin, which you can see here. There is even some alias, so I can call ClojureLsp to clean my namespace. So I will run this alias just to show you the API. So if I just line clean namespace, it has the dry option, so it will not make any changes to my code. First time the plugin starts, it will start analyzing your project, as you can see up here. And after the analysis, it will check your project namespaces and make the proper changes, or just tell you the changes it happened. So you can see it removes some requires which is not being used. We can check this open in this file. So actually, let me just show what this simple does. So this is a really simple project that fetch the trending repositories or developers from GitHub. So it has this main function. Let me just increase the font size. It has this main function which will fetch it, or the trending repositories or the trending developers for a language. You can see that I have ClojureSp already working here. When I opened the buffer, some lsp-mode just started the ClojureSp server, and I can see already some features working, like the hover function. If I hover over a symbol, it will show me all the reference of the symbol. If I hover over this function, it will show me the user down there. There is also the code lanes here. You can see that shows me all the reference of this function. You can configure, for example, to show up here. It will be like that. It would be. All right. So this main just called the GitHub API. So let's try to go to this code, right? So the first feature I have here is the lsp find the definition. So if I use this, I can go to the definition of this function. And I can see all the reference from this function as well with lsp find reference. So if I call this one, it will show me a single reference. And if I press enter, I can go to the function. All right, so what else? We can, for example, go to this function and see all the users of this private function using lsp UI, which is this pop-up that that shows the reference with lsp UI pick finding reference. So it's just a fancy way to see all the reference with a preview of the code on the left side. What else? You can see up here that we have some warnings. This comes from CLJ Condo, but just again, this is not a separated extension. It's not CLJ-Condo running manually or inside my Emacs. It's built in on ClojureLsp. So ClojureLsp is calling CLJ-Condo and returning the information following the LSP standard. And here we can use the first code action. So we want to remove this required as it's not being used anywhere. So LSP has this concept of code actions that are just commands that will do something with your code. So it will replace your code with another code. It will remove your code or something like that. So when I hover over something asynchronous, the LSP it's checking for all the available code actions for this line and this column. So if I try to call, for example, the code actions here, I can try lsp execute code action, and we can see there are 3 available code actions, which are cycle privacy, extract function, and clean the namespace. The clean namespace is a code action available for any time it will be available for the code actions. So there is even another command called lsp organize in parts, which will just call the clean namespace. So let's try lsp execute code action, and I will select clean namespace. And voila, we have the namespace correctly formatted and with no unused requirements anymore. So this is the clean namespace feature. I think this is one of the features that Cursive doesn't have. So it actually warns about the unused alias, but there is no easy way to remove all of them. I'm not sure, maybe could be wrong. All right, let's see other code actions like cycle privacy, which will just cycle the privacy of this function or variable, adding the private metadata, or just there are also configurations for adding the dash at the start of the function. What else? We have the extract function. So imagine I want, for some reason, extract this, this request here. I can call extract function, and ClojureLsp will move this to another new function, and I can now use the new another ClojureLsp feature called rename, which is one of the most used features, which will rename all the references of the symbol. So let's try lsp execute code action. Oh, actually, it's not a code action; it's just a feature. So you have lsp rename, and I can rename for new function, and voila, we have all the references renamed. This works for variables, for locals, for even for namespace, which will rename the file as well, and all other references. We can try on this public function here. So the fetching changing developers is being used here. We can try to rename it to foo, and we can see there is the foo function right now. All right, let's see another cool feature. There is completion, which is really useful. I can start type and call completion, and you can see that is the type variable, the type function for the Clojure core, or a keyword type, and even snippets, which are really cool completion items, which, for example, I can just type def, and when you see this $sign in the end of this function, it's because it's a snippet. So I can use this completion, and some code will be inserted for me, and I can just type the function name. There are a lot of snippets you can find here. So snippets for add comments, a lot of defs, functions, imports, let. So imagine I want to create a new let, I can just let and create this snippet and create my let binding. What else? Oh, that is this other namespace here called GitLab API, which is just a namespace with empty functions and implementations. So you can see here there is this unused public var lint. This is not built in on CLJ-Condo. This is part from ClojureSp, which is using a feature from CLJ-Condo to define custom linters. So ClojureSp, since it analyzes your whole project, it knows that this function it's not being called in other place, so it will have this lint. But there are cases where you want to suppress this linter, or doesn't make sense to be unused because it's used in another place that doesn't run Clojure code or something like that. So you can, for example, suppress this with CLJ-Condo ignore and pass on the vector what the linter you want to suppress, which is the Clojure-lsp unused public var, and then there will be no lint anymore. This will be applied just for this form, but you can configure this linter to be disabled or just for specific namespaces. So it's really configurable. You can find everything about it on the settings section. All right, let me check. There are cases where you have a custom macro like this one. So you have a macro that defines something, you just pass the name, and you can see CLJ-Condo is telling me that this foo is not resolved, but actually it's a macro, so this will be the name of the function. Actually, this is not correct, but the important part is that I want the CLJ-Condo teach CLJ-Condo that this function should behave like other macro function, like def. So that is the code action resolve macro. This is something that, as far as I know, only Cursivy has. So I can teach CLJ-Condo to link this, define something as, for example, a def. And then when I choose, it will ask me to save this configuration on some CLJ-Condo file, which can be my CLJ-Condo file, or my CLJ-Condo file on my home or on my project. And after select this, you can see CLJ-Condo is linking this as an unused public var, which is using def under the hood. This feature just edits the CLJ-Condo file manually for you. So if we check the sample and check the CLJ-Condo folder, there is the config hidden, and we can see here that there is the, let me expand this. There is the linked s that was added by ClojurelsP. So this was not done manually. It was CLJ Condo that it was ClojurelsP that added this configuration. All right. Let me see if there is other cool features. That is the format feature that I didn't show you. That imagine I have, I don't know, something formatted like this, or don't know, something missing here. I can try lsp format buffer, and it will format the buffer correctly using CLJ-FMT for me. This is the same feature used in the API. So if you try to format, it will do the same. So we can undo this and just call format. It will format, oh, actually, ClojurelsP format. And when I go back to my Emacs, it will be formatted. So here it is. And that's it. All right, let's see. Oh, there is the Semantic Tokens feature. It's a really new feature. There is no GIF here yet, but let me try. Semantic Tokens is something that the LSP can teach the editors how a symbol should, what is the symbol, or how the editor should highlight or add some color to the symbol. So here you can see that the def-n, it's a macro, so it has this purple/pink color. This is something that the LSP told to the editor that it's a macro, and then the editor knows that a macro should be linked with this color. This could be changed as well. So there are things that the editor knows how to link, for example, knows how to actually color. There are built-in symbols like def function, def-n, and def macro, but there are things that the editor can't know what it is. So let me go back to the GitHub API. You can see here we have the ref function. Without LSP, this color would be probably white because the editor don't know that this is a function, but it's just a token. But with LSP, we can see that it's coloring as a function. The JSON/read string as well, and other things like keywords and variables. I can try to disable the semantic tokens here so you can understand better. So let me try. Oh, I'm not sure if I will be able to disable completely, but I think there is a GIF here somewhere else. Let me find. There is this tutorial for Emacs for Clojure. I can share you the link later. It's just a tutorial explaining how to configure Emacs with ClojurelsP. And here's the semantic tokens. It's a kind of small. Let me try to increase. Not sure if you can see, but you can see that there is a lot of white tokens here without LSP and without CIDR. We can see that when CIDR code is evaluated, CIDR already adds some color, some highlighted some tokens, but LSP has a lot of more tokens like macro tokens, function calls, and some other things. So this is a really cool feature that is enabled on ClojureLsp, but it's not enabled by default on Emacs, for example. And I think the last one is the Courier Function feature. This is a really cool feature I really miss it from Java. On Java, we had the Courier function where I can see all the hierarchy of calls of all the tree hierarchy of calls for a function or for a variable. So here we can see that. Let me try to show you on this code. We have the main function. It calls the fetch items, which then call the fetching changing repos, which then called our new function. All right. So if I try to here call lsp max call hierarchy, it will show me this little buffer right here, where I can expand this node. Oh, actually, it's not working. Let me. Oh, right. So I can expand this node, and we can see there are two other functions being called, which are the new function foo and the fetching change developers foo, that are functions that are calling this request function. I can then expand the other one, expand the fetch change repos, expand the fetch items until I reach main function. So I can see all the hierarchy of calls. This really helps during refactor of your code. And that's it. Let's see. You also have the outgoing call, so you can see all the calls that a function do. The incoming is all the calls that that are calling this function or variable. And I think that's it. So let me see if I'm missing something. The API, the features on the API, or show this. All right. Let me go back to the slide. I think that's it. Well, thank you very much, everyone who is on this presentation. I'd like to thank you, Clojure Together, for the support. Clojure Together is supporting ClojureLsp on this quarter. This is already helping a lot, so thank you. I'd like to thank you also, Nubank, for helping and supporting me with the open source work. And thank you, Bruno, for this invitation. And that's it.